So, everybody knows that if you do a Rubik's Cube algorithm over and over again, eventually it'll return to its solved state. For instance, if you do sexy move 6 times, it'll go back to solved. If you do the U move 4 times, it'll go back to solved. If you do a T perm twice, it's back to solved. But why does it take 2 times, 4 times, and 6 times, respectively, for this to happen? Well, the answer is going to require a bit of background knowledge that I will be discussing here. So, first I'm going to describe a bit of a scenario. Now, say I have this pen, this snake-looking puzzle, and this juggling ball. And then every time I tap the table, they're going to rotate. So this ball's going to go where this one was, this snake's going to go where this pen was, and this pen's going to go back to the beginning. And say I do it again. So I'm going to tap the table again. It'll happen again. Say I do it a third time. And look, now they're back to where they started. And it took 3 times because there were 3 objects. So if there were 5 objects, it would take 5 times, 6 objects 6 times, and so on. Now, say I have these puzzles over here. Say I have they are all also moving at the same time as these 3 objects. So, say I tap the table, these 4 objects are going to move in a circle, and so are these 3 objects. So, here I go. So, these 4 moved around, and these 3 moved around. So every 4 times, these ones are going to go back to where they belong, and every 3 times these are. And then you may wonder, when are they all going to be back to where they belong? When are both these and these going to be back to where they belong? Well, it ends up, if you think about it for a moment, it makes sense. It's going to be the least common multiple of 3 and 4, which is 12. So that's the end of that little lesson. Anyway, back to the Rubik's Cube. We're going to do another little exercise to get us acquainted. We're going to look at what an A-perm does. We're going to look at an algorithm a little bit differently here. So, what I mean is, we're going to notice that when we do this A-perm, it's going to move this sticker here, it's going to move this sticker here, it's going to move this sticker back here. It does that. It's also going to move this sticker here, this sticker here, this sticker here. Lastly, it's going to move this orange sticker here, this blue sticker here, and this red sticker here. So that was actually exactly like the situation we just described. It was exactly like the situation we just described because we were cycling 3 objects in a circle, but we were doing it 3 times. And how many times is it going to take to get back to where they belong? If you have 3 objects spinning in a circle, 3 sets of 3 objects spinning in a circle, it's going to take 3 times because the least common multiple of 3, 3, and 3 is 3. But, alas, that's how you do it. Every Rubik's Cube algorithm can be decomposed like that, and therefore you can determine the cycles that it's broken into, and then find the least common multiple of all those cycles, and then you have the amount of times it will take you to get back to where they belong, where they started. So, for the example that we all remember watching a YouTube video, there was a guy that said, it's like 10 years ago, he said, all you have to do to solve a Rubik's Cube is do these 2 moves over and over and it will go back. Obviously that was a lie, but he did have a point there. It does go back. If you start solved, it'll go back to where it was. But it does take a long time, but you don't actually have to count every single time to figure out how many times it's going to take. You just have to do what I just did. So, when we do RU, what's it going to do? It's going to move this sticker here, this sticker here, this sticker here. That's going to be a 3 cycle. So, I'll scribble this out. We'll write down 3 for the first one. And then, honestly, so the other stuff takes a lot of effort. Or it's like, I'll just do it. So this sticker will go here, this sticker will go here, this sticker will go here. It ends up being 15 stickers long cycle. So we'll write down 15. Then edges is going to be this sticker goes here, 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 which is 7 long. And then there's another edges, which is also 7 long, so I'll write down 7. And then when we take the least common multiple of all of these, least common, what are we going to get? We're going to get 105. And that is how many times it will take us. I'm not going to do it here. That would take too long.